Hi everyone, it's Daniel from Esri. Today, I'll be going through the Manage Data tutorial for Arc GIS Pro. In this tutorial, we'll work with datasets that can be used for environmental restoration projects in and around the city of Christchurch, New Zealand. We'll preview and explore the data, clip it to an area of interest, and process formats and coordinate systems. The goal is to organize a streamlined data collection in a geodatabase that can be shared by GIS professionals working on related projects in the same geographic area. This tutorial can be pretty extensive, so if you get stuck or have questions, you can follow the step-by-step instructions using the Arc GIS Pro documentation. To start, download the Manage Data file from the Overview page on ArcGIS Online and save it somewhere convenient. You can find a link to this data in the description below. Start ArcGIS Pro and sign in. Then, start Pro without a template. Reset your panes for geoprocessing and open the Catalog view. It's important to note that we'll work with the Catalog view and Catalog pane. These are two different things, but we'll be using both in the tutorial. When you expand the folders in the Catalog pane, notice that a temporary geodatabase and home folder are created. Next, add the Manage Data folder as a new folder connection. Notice how the new folder connection now appears under Folders. Expand the folder to see all its contents. In the Contents pane, open the Planning Geodatabase and the Plan Area feature class. There are three tabs: Metadata, Geography, and Table. The Metadata tab contains the item description. In the Geography tab, you can click on some of the map features. And lastly, the Table tab shows a preview of the attributes of the feature class. Part of managing geospatial data is knowing its coordinate system. Go to the Feature Class Properties dialog box and expand Spatial Reference. Notice the projected coordinate system is WGS 1984 Web Mercator Auxiliary Sphere. Sometimes, you'll have data with different coordinate systems. For example, when we open the coordinate system for the Community Boards feature class, notice how NZGD 2000 New Zealand Transverse Mercator is different from the coordinate system that the Plan Area feature class uses. Next, we'll explore some of our data in a map. Select the following datasets and add them to a new map. You can also add new data to the map by dragging the corresponding layers. We'll do this with the Parks shapefile. Part of managing geospatial data is making sure to focus on your area of interest. In this tutorial, we want to create a collection of compact data that is focused on Christchurch, New Zealand. Notice how our layers extend well beyond the Christchurch area. To solve this, we'll clip our datasets. By clipping our datasets, we're essentially carving out the datasets to fit our desired extent. First, we need to find a layer that has the extent we're looking for. One way of doing this is by using ArcGIS Living Atlas of the World, which is a collection of authoritative geographic information curated by Esri. In the Contents pane, under Portal, click on Living Atlas and add a filter for administrative boundaries. Type New Zealand Urban in the search box. You can deselect the Details panel to have more room to see the layer names and information. Click on Tiles to view items with thumbnail images. Locate the NZ Urban Rural Indicator Areas 2021 feature layer and add it to the map. Next, on the Explore Tool drop-down menu, click Selected in Contents. Now, when you click a new map feature, the pop-up pane will show information for the layer selected in the Contents pane. Click on the Christchurch urban area. The pop-up pane confirms that the feature represents the urban area of Christchurch. This is the feature that we'll use to define our clip extent. Since we'll be using this layer often, we'll rename it to Urban Area. We now have a layer with the right extent, but we also need to store our new data in an organized manner. We'll do this by creating a new geodatabase and folder and setting them as our default locations to save the clip data. To create a new geodatabase, click on New File Geodatabase and create a folder named Christchurch Renewal. Open the new folder and, in the Name text box, type Christchurch Data. Then click Save. The new geodatabase is now displayed in the Catalog view. Notice how the original geodatabase is marked with a home icon. This means that it is still set as the default geodatabase. To change this, under the Manage tab, click on Make Default. Next, we'll add a folder connection to the new Christchurch Data folder so we can access it directly instead of browsing to it. Now, we'll change the home folder in the same way that we changed the default geodatabase. We can also add the folders to our favorites. As a favorite, the folder connection is now available in any Arc GIS Pro project. We're now ready to set up the clip tool. In the Contents pane, make the urban area the only selectable layer. Using the Select tool, click on Christchurch Urban Area. In the Geoprocessing pane, find the Clip tool. Right-click the tool and select Batch. The Batch Clip tool opens. A batch tool is a temporary tool that allows you to process multiple input datasets. Most geoprocessing tools can be run as batch tools. You can also save a batch tool to make it permanent. Confirm that input features or dataset is selected, and uncheck Add Output Datasets to an open map. Next, we'll select the input features. In this case, it's all layers except community boards, districts, and region. Once you add the layers, select Urban Area for clip features. We'll leave just the name variable in the output feature class name. This variable assigns the input layer names to the output datasets. Recall that some of our data is not in the same coordinate system. Before we run the clip tool, we'll need to change our geoprocessing environment settings so that the input datasets project to the New Zealand coordinate system. Geoprocessing environment settings are parameters that are not built into a tool but are applied to the output data when the tool runs. To do this, go to the Environments tab and click Select Coordinate System. Expand the layers and click NZGD 2000 New Zealand Transverse Mercator. Click OK and run the tool. Let's examine the new datasets we created in the Christchurch Data Geodatabase. Display the items as a list. There are 9 feature classes in the geodatabase. Open one of the feature classes and ensure that it's in the correct coordinate system. Select all the feature classes and add them to a new map. We don't need the original map view anymore, so we can go ahead and close it. The last thing we'll do is select the features in the community boards and districts layers that have areas in common with the Christchurch urban area. The reason we don't clip these files is because they represent administrative units. As such, they should preserve their spatial integrity. Open the Select by Location tool. Browse to the Boundaries Geodatabase. Select the 2 layers. Set Relationship to Intersect and selecting Features to Urban Area. Then click OK. 2 layers have been added to the map. Rename them in the Contents pane. These layers can add some more context to your Christchurch data, so we'll add them to Geodatabase. Open another tool in the Geoprocessing pane and type Copy Features. Open it as a batch tool. Confirm that Input Features is selected, then in the Batch Input Features, add the Districts and Community Boards features. In the text box, leave only the variable name. In this case, both of the input feature classes are already in the correct coordinate system, so we don't need to make an environment setting. Turn off the community boards and districts layers in the contents pane to avoid confusion and then run the tool. Then remove the original community boards and districts layers. In the contents pane, move the district layer above the base map layer and move the community boards layer above the districts layer. Zoom into districts layer. Both layers extend beyond the Christchurch urban area because they weren't clipped. However, only the features that intersect the urban area are included on the map. Make the catalog view active and notice how the 2 feature classes are now included in the Christchurch Data Geodatabase. In addition to these steps, you can also update metadata, save your layer files, and load data in Arc GIS Pro. You can view those steps in the Arc GIS Pro tutorials page. In this tutorial, we created our own geodatabase and used geoprocessing tools to clip and copy our data. We also added data from the Living Atlas and became more familiar with the catalog view in ArcGIS Pro. These tasks help us manage and prepare our geospatial data for future use.